Yes, sir.
Okay,
Yes, sir.
without any interruption. Okay, so now today this is a first lap of a signal and system, right? So I would like to introduce about the basic tools, the softwares that we are frequently use in the laboratory sessions, especially the MATLAB and LabVIEW. And I am sure some of you have some exposure of a MATLAB and LabVIEW, right? You have even worked earlier, or you may have some exposure. You have attended some workshop regarding the same software. These are the basic mathematical toolbox. With by using this, most of the experiments will be conducted of a signal system, and as well as in the next semester you have a advanced digital and analog and digital communication, and in next to next semester you have wireless communication. So we extensively use this software for the simulation purpose. So today I'm going to start with some demo of a MATLAB toolbox, right? And then later sessions that we'll discuss about the LabVIEW, how LabVIEW will work, and what are the main things, what are the main blocks that you need to concern whenever you are experimenting some things on for a for a digital communication, right? Okay, so here in this first lab, I will just give you introduction about the MATLAB toolbox, especially where I am going to start with the Scratch. I am assuming here that you very few of you have a prior exposure of a MATLAB. So to make the flow continue, that I'm going to start with the first experiment. In the first experiment, we will just discuss about how the MATLAB will be work. So introduction of a MATLAB. This will be your first experiment, right? And then in the next experiment, we will discuss about how to plot the basic signals using a MATLAB toolbox, like as a unit step function, sinusoidal signal, cosine signals, right? And the basic properties of a plot toolbox. Then we will discuss about the in the next experiment we will discuss study about the properties of a system, like the linearity property, time invariance property, and all this by using a MATLAB toolbox. So today I am going to share my screen with you where the MATLAB is installed. The MATLAB is very basic tools for a mathematical toolbox. Generally MATLAB has been developed to start working to simulate the mathematical related things earlier day, but now it has been found the mathematics is not only limited with any particular branch of mathematics. It is related with some branches where the mathematics is highly used or extensively used, like say mathematics in communication branch, the mechanical branch, where mathematics is extensively used. So looking to that, MATLAB has developed some toolbox related to this particular subject, like the image processing toolbox has been developed, the machine learning toolbox has been developed, the communication toolbox has been developed, and then the MATLAB has been adopted as a simulation tool uniformly through the many branches, like as electronic communication, mechanicals, and all. And they have found most of the functions or simulations can be beautifully done, or the graphs can be beautifully visualized in a MATLAB tool using a MATLAB, right? Similar to the MATLAB, the Python has been developed, and Python has a more advanced command of a MATLAB. But looking to that, if you thoroughly know the MATLAB toolbox, so it will be a bit easy for you to understand the Python concept, because Python is actually object-oriented programming concept, and most of the commands and most of the structure of a Python is basically developed using a MATLAB. And whatever the command in a MATLAB that have some dots, the files that has been, the MATLAB is basically programming a C++ language. It's an object-oriented programming language. So structure-wise, the MATLAB and Python has not too much difference, even though the Python has bit advanced compared to the MATLAB, because if you are doing the machine learning and something, so they have a ready-made available commands or ready-made libraries are available in a Python, which is missing in a MATLAB. But despite of this, the MATLAB is still used in mathematical as a widely adopted. MATLAB is widely adopted in most of the engineering branches, and most of the experiments have already been developed in a MATLAB. And parallel to the MATLAB, the Scilab is also developed. Scilab is one software which is openly available. MATLAB is a paid software. If you individually, it is not possible for you to purchase MATLAB. You can use the student version, which is freely available, right? And there is one application also. You can even in your mobile, you can even implement the MATLAB, but that is very basic. They not covers the very advanced toolbox. So it has some limited capability and limited use. But if we talk about there's some advanced toolbox. If you want to purchase some advanced toolbox regarding the image processing toolbox, communication toolbox, that you need to purchase the whole software, and the cost of this whole software is very high. That's why the institute will provide you, and the students are basically working on the software which is provided by the institute, right? Students are even use the crack version on their own laptop, right? But otherwise the license version is not available, freely available for a MATLAB. Unlike to that one, Scilab is totally freely available. So Scilab and Pythons are generally open software. They are freely available. But Scilab has not limited capacity, and Scilab is not as powerful as MATLAB is, right? So most powerful toolbox and most powerful is Python. And the secondly, you can consider MATLAB is even a powerful toolbox, but Scilab is not that much powerful as the MATLAB is. But if you have some limited functions, and if you want to implement some mathematical function which are very basic function, then the Scilab will work, because Scilab is open software, right? Even though it has not the parallel capacity, and it's in many things it is lacking, but compared to the MATLAB, but still the Scilab can be widely used because it is a free software, right? So these are the three which are the parallelly working, and which has some plus and minus compared to others. But these are the toolbox which are basically used for a communication engineering students to simulate their experiments of a various subject, right? So now today we are going to start with the MATLAB, and there is one another is a LabVIEW. So LabVIEW is a GUI based software in which you do not need to program. It doesn't provide a scripting. It's not a script language, right, where you have to type some things and then you have to run the things. It's like as a dragon. It's kind of a GUI in which everything is in form of a block. If you want to program the LabVIEW, then you have to drag and drop the blocks from a main screen block diagram panel. Then you have to join down, and then you have to run this, right? Even while loop, for loop, and all the loops are also available in form of a block. So this is a GUI base, but compared to the MATLAB, the LabVIEW has a more advanced software and widely used in industrial automations. The LabVIEW is widely used, right? For example, if there is one industry, and in this industry, in the field, there are some mechanical and chemical. So let's say there is some chemical plants, and chemical plants has been deployed in some of the fields, and any engineers want to observe how the thing is going on in the field by sitting in their own office, right? The office may be far away from the field, maybe 1 kilometer or even a larger area. So by using the LabVIEW, they can observe, and by using the LabVIEW, it is also possible to control that plants, to increase the chemical supplies, to decrease the chemical supplies, to stop the chemical supplies in some kind of a contamination. So all these things, all the parameters can be controlled by the LabVIEW software by setting remotely from the plants, and that facility is provided by the LabVIEW. So LabVIEW will provide the interfacing capability, right? You can connect with the real world, and you can even it provide the monitoring of plants by setting the remote end, as well as the controlling capability by setting at the remote ends, right? This is not possible with a MATLAB. So if you go in a some Bangalore or some other state, there are some companies in which even in SLS company in Vijayanagar also, there are some projects based on a LabVIEW, right? So develop a model using a LabVIEW. So LabVIEW is widely adopted in some industrial standard, because in LabVIEW, the main part over here is the connected with a real-time hardware, right? It provides the capability to connect with the real-time hardware. So this is the flavor of this LabVIEW software, and MATLAB is basically used for a research point of view, and for understanding some concepts which has been theoretical laid down in the book, right? So MATLAB is not that much powerful as the LabVIEW from industrial point of view. Right. So these are the softwares, and even Python is basically used more for machine learning purposes. So these are the basic difference between this all the softwares and the tools that you have to came across within a next semester and this semester in various laboratory sessions of your subject. Now I'm going to start my sharing of my screen with you and give you a idea about how the MATLAB is basically working. We will discuss today about very basic functions of a MATLAB which you have to frequently came across. And the another things that I need to highlight is how to make a file, how to put your functions, how to use the help effectively, what are the main components of a MATLAB, and how the MATLAB structure is basically working. So these are the things, these are the stuffs that we are going to discuss in this laboratory session. And hopefully at the end of this laboratory sessions you start to download the MATLAB from somewhere, and if even at least the MATLAB, the basic versions of MATLAB you can download using your mobile app from Android, and you start to working on that, right? So at least I am expecting over there, because in the next, when the next lab comes, so we may have some more exercise and we will go with some more detailed programming of a MATLAB. So before, prior to this, it is the lab, it's like a refreshing kind of a labs in which you have to be acquainted about the MATLAB software and the MATLAB environment. Right. Okay, now I would like to know how many of you have a prior exposure of a MATLAB. Can anybody raise their hand who have a prior exposure of a MATLAB earlier to the semester? No one, right? Okay, so I think you all are new to this one. So
Yes.
looking to, yes, okay, so we are going to start with the MATLAB software, right? I'm going to share my screen with you, and once it is clearly visible, you let me know. Okay, are you able to visualize the screen? Command window is written on the screen.
Yes, sir.
Okay, so see, this is a MATLAB 2017A, right? MATLAB is basically have a two versions. In first, if in the year of 2017, from January to June, if the MATLAB version is available, then it is known as A, right? After some modifications in after July, from the next half of the year, from July to December, the new versions of MATLAB comes, it is known as a 2000B. So A and B is basically depends on which one is released earlier. The earlier version the version of MATLAB which released earlier is known as A, and the version which released later it is known as a B, right? And as per the number of years. So now I have a MATLAB 2017A is available in my laptop, and you can download it. Trial version you can download, but the trial versions is working only for a 1 month. So if it's a, you can download the correct versions as per your feasibility and all by using, but it make it available only on your laptop. You can use it personal use. You do not try to connect with the college institute, right? Because in institute the such kind of a correct versions is to be banned, right, as per the regulations and rules. So I suggest you, if you are using the correct versions, it is fine, but make it available only at your laptop, only at your end. Use it, make it personally, make it your personal use only. Okay, so let's start with this one. The first one is this command window, and this left to this command window there is a current folder. So this current folder will defines how many folder has been opened by entering in the MATLAB, right? And this is the command window. In the command window we can individually run the command. We can individually run the command. If you have acquainted about the C language, so we don't have that much capability, right? We can have a file, we will write the program in a file, and then we will compile the file at the end, and then the output is produced. So unlike to that one, in the command window you can individually run the code. And if you are making a file, I will even show you how to make a file. If you are making a file even, then once you run the file, so the things regarding the input and output will be automatically available in a command window. Let's take example. If you want to add the two number A and B, so that you have to write a code to enter the value of A from a keyboard in a file, right? And enter the value of B, and then the output C it will be produced as addition of A and B, A plus B. Hi, okay, so is it available? The screen is available to you? Are you able to see the command
Yes,
window?
sir.
Yeah,
Yes.
okay, because connection was lost meanwhile. Okay, so now then C is actually the addition of A and B, and that you want to produce this output on your command window. So this is possible to do this. and whatever the A and B that you want to enter from keyboard, that is available in a command window. Once you enter that value, then the output C will be produced or appear display on the command window. So command window is basically a screen which deal with the inputs and outputs, in applied the inputs and whatever the output is produced by the code. So the command window is basically have a list of these things, right? Whatever you have given. But this apart from this all, in the command window there is a possibility that you can individually run the code line by line. That is also possible, right? And individually you can have a command and you can make your own program in command window also. But the disadvantage with the command window is that once you will switch off your you will switch off from a MATLAB, then all the data will be lost. So it is basically advised that you make a file and store the programs in a file. But here today we are going to see how the command by command command by command the programs can be run using a command window, right? Okay, now one another things that I would like to highlight over here is MATLAB is basically a mathematical toolbox. So see, mathematics is involved in or integrated in most of the branches of engineering. So where new functions have been built up or new foundation has been comes up, new formulas have been built up or invented, so all will be included in a command window. So command window is very powerful because the same things if you want to do by using a C and C++, they do not have a ready-made command like as if you want to integrate the things, right? So C fails over there. You have to write a lots of lines over there to integrate the things and to differentiate the things. And here the same thing can be work in a MATLAB by using a single line. So that way it is very powerful. So to implement the mathematical functions, the MATLAB is very powerful because they have a ready-made commands, right? And by using this ready-made commands, whatever you can do in a C by writing thousands of lines, that you can do here to writing only hundreds of lines, right? So that way it is very helpful. And even the Python is even advanced on this. So whatever you write in 1000 lines in a MATLAB can be even conserved to only 100 lines in a Python, right? So it is advanced in that sense. Okay. For example, if I have made a 50,000 more than 10,000 lines program during my PhD, and if I have done the same in using a Python, so I have taken only 1,000 to 2,000 lines, right? Because it is concise approach compared to the MATLAB. But still, the MATLAB is still more powerful compared to other language in implementing of the mathematical functions, right? So first we are going to start with a linear algebra, and in a linear algebra we will see how the linear algebra can be beautifully and very concise way implemented using a MATLAB toolbox. So first we will see how to produce some matrix, how to do some basic operations of a of matrix, how to use some advanced linear algebra commands using this toolbox, like how to find the rank of a matrix, how to find the eigenvalue of matrix, if you want to separate the particular columns or particular row from the matrix, particular elements from the matrix, then what is the command, how you can do this, how you can produce the identity matrix and all. So we'll discuss first part is about the matrix related things, how we can apply the different matrix formulas over here. And the second part we'll discuss about the some plotting toolbox. If you have a function like a sine and cosines, maybe a ramp function, so how you plot this, how you can change the color patterns, how you can change the size of all, and all these things that we are going to discuss. And then we will discuss about the what is the MATLAB help, how powerful the MATLAB help is. If you confuse in some applying some commands, you want to learn something new, then the MATLAB will be helpful. Then in a final stage we discuss about how to make a file, how to run this file, how to store these files, and all these things, right? So these are the basically things that we are going to learn. So first of all, we want to start with very simple things. If you want to add the two numbers, so how to write over here? So every numbers will be stored in some variable. So I say my variable is a. A is a variable. Variable names you can give any of the names of as a variable name. But the one question is that you should know about the some structure of a MATLAB. You should know what is the command, right? And you cannot give the similar name of variable as the command is already there in the MATLAB. Like as a plot is a one command, and you cannot start any variable as a plot is equal to 3, right? Because it will be confused. And then if you write like this one, so already plot command will be, a plot file is already available as a plot.m in a MATLAB systems that will be run. So make sure whatever the variables name you are giving, they should be not be the identical or similar to the command name of a MATLAB. So we start with here a is equal to 3. Let's give the value. A is a variable, and now I assign the variable as the value of 3. Now as the second variable is b, I assign the variable as a name of 2. I think it's a visible, right? For font size and all these things, I think
Yes, sir.
don't matter from your side. Okay.
Yes, sir.
And every line will be terminate with the semicolon, right? So semicolon means the end of lines. It's if you terminate every line with a semicolon, so this line is not unnecessary display on a command window. If you are writing the same thing in a file, so if you do not terminate anything with the semicolon, so it will be unnecessary appear in a command window. But if you terminate every line with this semicolon, then it will not appear on a command window. So those things you want to intentionally appear in command window, so do not terminate with the semicolon. Okay, so a is equal to 3, b is equal to 2. Now I write c is equal to a plus b, right? And then I enter this. So it shows the 5 value, right? I have not terminated the C with the semicolon because C is the output of the addition that I want to display, right? So A is equal to 3, B is equal to 2, and then C is equal to A plus B is directly give me the answer. So that way you can use the manipulation of various arithmetic command of plus, minus, division, and all this. Okay. Now, the one another things that I would like to highlight, if you want to multiply, right? So for a multiply, we are using star. So star is the actually is a sign of multiplication. Then if I enter this, so it multiplies a and b and give me the answer as a c. So c stores the variable outcome of a multiplication of a and b, that is 6. 3 into 2 is equal to 6. Now, here, this is a simple things, right? And if your command window is full of such kind of a mathematical equations and that you want to start from the first line again, then there is a command known as a CLC. So CLC will clear all the things in a command window, and that you make the opportunity to start the or type the command from a first line. So CLC is a command, you can note down this. Now, this is a simple mathematics. Now we deal with some matrix. Let's say you want to create a matrix of a 3 cross 3 size. 3 cross 3 size means you want to create a matrix which has a 3 column and 3 row. So you simply write A is equal to inside a square bracket. So square bracket indicate the A is been assigned as a matrix. So the first line, let's say you want have a number of 1, 2, 3 in a first row. In a second row, you can want to place 4, 5, 6, and in third row it is 7, 8, 9. So between columns, you put the space only. So 1 space 2 space 3, right? Then semicolon. So semicolon is inside a square bracket. It indicate the row is going to change from here. So 1, 2, 3 is placed in a first row, right? Then we may have a 4 space 5 and then 6. It means the second row consists the 4, 5 and 6 value, and now the 7, 8 and 9. So it means the third row consists of 3 more values, 7, 8, 9. Then I enter this one, so it will be display 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Okay. Now, let's say you have a different matrix and different matrix is a B, right? So B I will write in the same way. Now you have up and down key. By using up and down key, you can repeat the command which has already been implemented earlier, right? Okay, already written here. So rather than A, I may use the B. So the B is my matrix and I change some value of variable. Let's say 4, 5, 6 here, and then would be 1, 2, 3, and then it would be 7, 8, 9, and then I enter this. So B is created with again a 3 cross 3 matrix with the elements which has been displayed over here. Now if you want to perform the some operations on a matrix, like as you want to add the matrix, right? So you want to add the matrix, so that will be assigned as a C is equal to A plus B. You can simply add the matrix, right? And what you write here, percentage sign indicate it's a comment. So whatever you write after the comments, that will not actually execute it. That is only to increase the readability of your program. So if you are writing a program for multiple lines and every lines want to memorize, or if somebody who is unknown to your program and if they are reading those, so they have he or she is able to know that which command or which line is used for which purpose. And that's why the thing is that we are writing a comment. So comment is actually start from a percentage sign. So I say it's a addition of matrix. So that is not going to display addition of matrix, right? And after this, if I run this one, so it will add the matrix A and B as per the matrix operation. Every elements to elements addition will be done, and then finally we will find the addition of A plus B, and it will be stored in C. Right. Now if you want to multiply the things, so that is again C is equal to A multiply with B, right? And then it will be do the matrix multiplication and give you the answer. Now, so this is the way how the linear algebra operation, like as a creation of matrix, the addition of matrix, the multiplication of matrix can be performed. Now move to the further step. Let's say I type the A and then enter, so A will be displayed. Now I want to extract the components individually. Let's say I want to extract the component. Let's say, okay, I type B. Sorry, I think it's more better because A I have written a sequence. So this is a B, and if you want to extract some components from B, right? Extract some components of B. For an example, if you want to extract this component 2, right? You want to separate it out from a matrix. So what is the indices of this component, and how you make it extract, or how you make it display on the computer screen. So that is the way. The first element in the first row and first column is your first element, right? If you want, if, we have two indices, one dimension indices and two dimension indices. In two dimension indices, we can define by row number and column number. And in a one dimension indices, we can have only element numbers. We don't have a row number and column number. So this 4 is simply considered as an indices 1. Then this fifth one is considered as an indices 2, element number 2. 6 is 3, right? Then the second row, first element is known as a 4. This is fifth. This is 6, right? That one is 7. This is indices number 8, and this is indices number 9. So you let me know if I want to extract this 2. So what would be the indices? How you write? I have to write this indices B inside a bracket the number of indices, and then they will display me the number. So if I want to extract this 2, so what is the indices in a single dimension?
2, 2.
2 is a indices, but indices means the location, right? So what is
Sir,
location of
5.
this?
We will
5,
write
yeah.
5, 2, 2.
5, exactly, right. So that is the 5. So this is the one way how we show the indices. This is the, it gives a 2, right? Now this is a single dimension indices. Now if we want to convert them into two dimension indices, so that we write the column number and row number. So that 2 is located in a second column and second row. So we write the 2 comma 2. So 2 comma 2 and matrix is B. So B inside a bracket 2 comma 2. It means whatever the elements that we are going to extract, that place in a, or that sit in the second row and second column, and that if you give the enter, then it will be give us the value of 2. This is very interesting. If anybody you want to extract, then you can extract. Now again I have a similar exercise. If I want to extract this 6, right? So anybody will let me know what is the indices in a single dimension indices if you want to extract this 6?
3.
3, right? So it's a third element. So that is they give us a 7, right? And if the same elements can be extracted by using a two dimension indices. So what is the way how to represent them in a two dimension indices?
सर आंसर 6 आना चाहिए ना, 7 क्यों आया?
6.
आंसर 7 आया सर.
Okay, sorry. Okay, sorry, it's my mistake. Yeah. So B can be defined in this way. This is the first element 4, then 1 is the second element, and 7 is the third element, right? Then we will move to this fifth. Okay, so it will be first to collect all the elements from a column wise. Column wise means the first column, first row is the first element, first column, second row is the second element. So 4 1 7, then 5 to 8, and then 6 3 9. So in this way, if you want to collect the 6, so what is the element number? Okay,
7.
again I repeat. 7, yeah, right. Because if you go column wise, So first column all the element, so 3. The next column, first element is the 4, 5, 6, and then 7. So if we write here the B 7, then it will give us a 6. So right, so that way we can have a answer. Now if we want to extract the same element 6 by 2 cross 2 indices, right, the row number and column number, so how we can extract this?
B1, 3.
Yes, first row, right? It located in a first row. So first is 1. 1 indicates the row number, right? The number row number. And the second element indicates the column number. So 6 is located in a first row and third column. So that we will write here B 1, 1, 3. Okay, right. So it means the first row, we are interested for the elements which located in the first row and the third column. So that is B1, 3, right? And then if we enter, it gives us a 6. Okay. Now again, I make it CLC, make it clear. Okay, that way you can element by element, you can extract the elements from matrix. Now we will see if we want to extract row wise, I mean it's not element but complete row, right? We are interested to extract the complete row. Like as I want to extract the first row, all the elements of first row, right? I'm not interested about the column number. I am interested only about the row number, and I want to extract all the elements of the first row. So how we write? We write B matrix first row. Row number we define, but we don't define a column number. Instead of a column number, we write the colon only. So colon means don't K, right? 1, colon. It means the first row and colon number is don't care, right? We don't interested for a column number. It means all the elements of a first row should be indicated. If I enter this one, so it give me a 4, 5, 6, all the elements of a first row. Is it right? Okay. Now if I want to extract the similar thing for a first column rather than first row. First column means I want to extract the 4, 1 and 7, right? So how these indices are going to change? Can anybody? First, now the question is different. I don't want to extract all the elements of first row, but I want to extract all the elements of first column, right?
Sir, colon,
Colon,
comma.
comma, yeah.
Yes, colon means in the position of a colon row, we write a colon, comma. Okay, in the position of row, we write the colon, then comma, and then the number of column, right? So it's a first column, right? And all the element of first column. So that will give us the 417, right? So if we want to extract the only first row, then define the row number, but don't define the column number. And in this case, we write only the colon in the column number. If you want to display only the all the elements of any particular column, then we write only that column number, but we don't define any row number. We write simple colon in the position of a row, right? I think it's clear. Okay, now, but the question may be again twist. If we want to extract some particular elements, right? Means particular elements we can define by indices, but we have already done this. But particular elements means the set of particular elements. Like I want this element 5 to let's say 5, 6, 2, 3 only, right? So how you define? Only 5, then 6, then 2, and then 3. I want to define this. So how we can define this? How we can shortly write this? This is very interesting. So let's say if I want to define only the small subset of matrices as which consist only 4 elements. So first 5, 6, 2, and 3. So 5, 6 is located in a first row, and 2, 3 located in a second row. 5, 6 is located in a second and third column, and 2, 3 is also located in second and third column. So how we can define this? So the way is this: we can start with the first row number. So what is the row that we want to consider? 2 colon and means all the elements starting from second row to we write here 1 colon 2. I means 1 to 2. We want to move from 1 to 2 with a step of 1. That we will discuss regarding this one in a vector notation in the next to this. But at this point, you consider Is it yeah, okay? My voice is audible to you?
Yes, sir.
Yes, sir.
Okay, so what I would like to highlight is 1 colon 2. It means starting from a first row to this last row is the second row. Means first and second row, all the elements of first and second row, and the column number we even need to describe 2 and 3, right? So it means we need the elements of a matrix which lies in a first and a second row, right? First and second row, and second and third column, right? So we define first and so if we go with the first and second row, so it consists all this. But then we again specify the column number also, and column number defines we are interested for the elements of second and third column only, that have only these four elements will falls in this category: 5, 6, and 2, 3. Right? 5, 6, and 2, 3. So if I write over here and enter, so it gives a 5, 6, 2, 3. Now again, I type the matrix B, and now the questions throw. I throw the question to you. If I need elements of 1 to 7, 8, right? I need elements of 1 to 7, 8. Then how we can do this? 1 to 7, 8. Anybody? B, what I have to write inside a bracket? 1 to 7, 8. We need a subset of this matrix as a 1 to 7, 8. So how we
Sir,
can define this?
2 colon 3.
2 colon 3, yes, because 1, 2, and 7, it lies in a second and third row, right? So it's a 2 colon 3 means the row positions of second and third will be considered. And what is the
1
column
colon.
position? 1 colon 2.
Sorry, sir.
Yes,
1
1
colon.
colon. Okay, okay, right. Okay, so that is 1, 2, 7, 8, right? So that way we need to consider. Okay, now uh, that may even the questions may be even if you want to consider only the corner components 4 and 6, 7 and 9. So how we can do this, right? So that is even interesting. So but to understand this, you should have to learn about the vector notation, and once the vector notation is done, that you can separate any elements out of this. But before this one, that I will just tell you just a way how we can do this job, right? So in a if you want a corner element only, so how many elements you require? First, four is lies in a which row? First row. Then we require a 7, right? So 7 does lies again in a first row. Then the next corner element is a 6, which lies in a first row but third column, and 9 does lies in a third row and third column. So how we write this one? So we will write in this form that we need to highlight these elements in such a way that it should looks like one one not consider all the elements, because if we consider all the elements, one column, so it will be goes in continuous manner. So this all the elements we consider, we want only 4 and 7. So we write with a step size 2, and then we will move 3, right? 1 colon 2 colon 3, it means 1, then the step size 2 means 1 plus 2 means the next would be a third, right? Next would be a third row. So first row and third row will be included, but the second is not going to be included. The same we write here. This all the elements of column wise we can have 1 colon 2 colon 3, right? Okay, so now I just enter this, so it will be give us the only corner component 4, 6, 7, and 9. What does it mean? That we later discuss in this in the same laboratory sessions, how we can define the vector. So vector is defined as a 1 colon 2 colon 3. What does it mean? It means if I type here, it means we can have only two elements, 1 and 3, right? 1 is the initial value, 3 is the final value, and the 2 is thus defines the step size. So that we have a 1, then the next step size is 2. So after 1, 1 plus 2, next because of step size 2 will be added in initial value. So next value 1 plus 2 becomes a 3. So we have only 1, 3, 4, 6, 7, and 8, 9. All are there, right? Okay, so this is the way how we may define defines the element, right? V may defines the element. Okay. Okay, so now we will move to some matrix operation in which we will discuss. So this is also again another way by which we will put the square bracket, and in the square bracket we defines the row number. So row number 1 and 3, right? And the column number is also 1 comma 3, that which elements are fall in a first row, and third is 4 and 6. Third row and first element is 9, so all will be displayed. So this is another way by which you may define the specific elements only, right? I hope you understand this concept very well. Okay, now we move to some vector operation. So I write comment line over here. Comment line means it is only for your readability, user readability. MATLAB will ignore this line. MATLAB will not consider and the calculations of mathematical operations of this line, right? We will discuss about the vector operation. So in the vector operations that we define, how the vector is defined and how the vector is different than the matrix. So in the matrix we can have a picture of row and column, but if we have only row, we don't have a column, or we have only column but we don't have a row, then it is known as a vector. So vector may be either 1 cross n size. 1 cross n means 1 row and n elements, or 1 row and n columns. Or it may have n cross 1 size, means n row and 1 column, right? So it may have variations according to that one. Either it has only row, not a column, or it has only columns, or I mean single row and multiple columns, or it may have a single column and multiple rows, right? So that we define in a vector operation here. How, if you have to define this vector, how you define the vector like this way: 1 2 3 4 5 6, right? So what is the size of this vector? 1 cross 6, right? It makes sense that it has one row and 6 elements, or 6 columns are there. And if we if we display this, that it shows 1 2 3 4 5 6 single row and 6 elements in each in a first row. Now the operations of matrix are remain same to extract the particular elements and all. But here that I would like to highlight something very interestingly for you, is that can, if some between element 1 and element 2, and between element 2 and element 3, if there are some relationship, mathematical relationship, right? Because if it is like that, so can we have a shorter formula by which we do not have to type all the elements, but the elements are automatically generated? Yes, answer is yes. We can do this, right? For example, between 1 and 2, we have a, what is the mathematical relations of all these elements? Every next element will be coming from incremental of previous elements, right? So 2 is basically coming from increment of previous. 3 is basically coming from increment of a 2. And so we will define in this form, we will write the first element from where we are want to start. So we want to start from the element first element, and that is 1. So we write 1. Then we write the column, right? The column is indicate that we have to define the step size. So we will define the step size 1. It means every next element will be of incremental by 1 to the previous element. So first element, this one is the first element from where we want to start. This one is the step size of a movement, right? This step size will be added every time to the previous one and to produce a new number. And then we finally write here where we have to stop, right? We have to stop. In life also, if you are starting from somewhere, so we can write here 6 is the last element. In life also, if you want to start something, so what is the main important part? You should know from where you are going to start. So initial position should be known, and what is your object, what is your goal of life. So you should know the final position, right? And meanwhile, in between the final position and initial position, you should have to define your step, how rapidly you are moving, right? How rapidly you are moving towards your goal. So similar like this. So in this argument, there are the 3 numbers are there. The first number is the initial number from where the vector is started. The last number indicate the destinations from where the number should stop. And this one will define the journey from 1 to 6, the step size, how to move from 1 2 6, and if I enter this, so it will automatically give to 1 2 3 4 5 6, right? Now one, this step size 1 is by default, huh? If somebody are forget to write this one and simply write here 1 to 20, right? So, and don't write this 1 colon 20, so don't worry, because it automatically consider as a step size 1. If you have to specify the step size, so it will be follow that step size, but if you not specify any step size, so it will be follow the step size as a 1 by default. So by default, so if you forget the middle arguments to put over here, then don't worry, because it will be considered by default it is 1. So that will show us the element starting from 1, step size is not defined. It means by default it is 1. So it is 1, 2, 3 up to 20. So that will give us the 1 to 20. So this is one very important part and consideration, right? 1 to 20. So starting from 1, then 2, then 3 up to 20, we can define like this. So this is very important. Now, I would like to ask some questions from you. I require this elements, right? To so how I can write? What is the shortest formula to write this? Anybody of you can let me know?
A 2 colon
A is equal to
2 colon
2 colon
2
2 step size. Yes, because between 2 and 4 step size is 2. Okay, then
16.
6. Okay, uh, okay, right. But now if I write instead of 16, if I write 17, so 70 will not display, huh? Because after 14 the next step size is 16, but after 16 the next step size is 18, and we have to stop at 17. So 17 will not display, but it will be not cross the 16 again, right? So this is the way how you define this. Okay. Now very interesting, sorry. Now very interestingly, I want to multiply something. Let's say 1 to 6. There are 6 elements are there, and I can have a second matrix starting from 2 to 12 with a step size of 2. Uh, so this is 2, 4, 6, 8, 10, and 12, right? So there are two matrices A and B, and with different elements. Okay, now if you want to do some operation between two vector A and B, then you make sure their size would be same. Their size would be same. If a vector A has a 5 element and vector B has a 6 element, so no any operations is going to perform. So it is expected by the MATLAB that whatever the operations you are applying on two vectors, both should be same in size. Same in size. So if one have a 10 elements, second one is also have a 10 elements. If one has a 20 elements, second one is also a 20 elements. So both should be same in a size. So make it sure before doing any operation. Otherwise it shows the error. So here we have make it same because both have a same element, 6 elements, 1 cross 6, and size of both the vectors are 6, 1 cross 6. Now we want to multiply these two vectors. So as earlier we have done for a matrix, we are multiplying A and B. Oh, it's a bad luck. That's showing the matrix multiplication is not possible. That shows the error. And the reason behind this is that if you are directly multiplying A and B, it will consider as a matrix. A is a matrix. So if A is 1 cross 6, so for a matrix multiplication, so B should be 6 cross 1. B should be 6 cross 1. Then and then multiplication is possible. So what we need to do here, we need to make B is equal to B dash, means invert. B dash means a transpose, right? We want to transpose. So what happens? This rows are converted into the column, and that becomes a B becomes a size of 6 cross 1. And now A is 1 cross 6 and B is 6 cross 1. So if we are multiplying A into B and assign something to C, right, then it is possible, and the final outcome would be 182, right? So 1 cross 1, final output would be 1 cross 1 matrix, and it would be 182. It will be done. But now sometimes you are not interested. Again I invert them back. In transpose to transpose gives the same matrix. So again I here like as a B is equal to B dash, and then we can have a 2 4 6 8 10 and 12, right? Now the questions will be asked from your side is like that, rather than matrix multiplication, we are interested multiply elements by elements. I mean, the first element of A should be multiplied with the first element of B, and the second element of A it should be multiplied with the second element of B. That multiplication is known as element to element multiplication, or known as a point to point multiplication, where we are not following any rules of matrix multiplication. We simply multiply the matrix similar like as we are multiplying two number, but the positions should be matched. If the positions of A, if some element in A is a third, and it should be multiplied with only the other matrix or uh, other vector which has say similar positions, right? So if you multiply 4, it's a fourth position. So we multiply with the 8, which is also located at the same position in matrix B. So if you want to multiply this vector with say position to position, then we can simply write A dot n star, and then B. We cannot simply write A in multiply by B, because otherwise it considered as a matrix multiplication. So what we have to put before any operation, like as a multiplication, maybe a division, maybe a power of operation, before that operations we have to put the small dot, and dot will tell us the MATLAB that the users are interested for a point to point multiplication, not a matrix multiplication. So here if we define C is equal to A dot star then B. So dot multiplication. So that then what happens, what you expect here, multiply element to element, 1 with 2, that will be 2, 2 with 4, that will give us 8, then 3 is multiplied with the 6, that will give us 18. So that is the point to point multiplication, right? Point to point multiplications. Okay, now if you want to make a square, but again you don't want to have a matrix multiplication, you want to make element by element square. So you can write A dot star A. It means element by element multiplication of all the elements of A. That is 1, that is individually square will be performed. 1 square is 1, 4 is the square of 2, 9 is the square of 3, 16 is the square of 4, and the same way it follows in the same case, right? Okay, so this is a very interesting, and from here we understand how the point to point multiplication is possible using this matrix multiplication. Now, not spending a time too much over here, that I will directly came across some plotting functions, right? So this is a matrix, how the matrix is to be considered. Okay, so now I directly come to some plotting functions, and this plotting function is basically to understand the concept of how functions like the sine and cos is to be plotted using a MATLAB. Okay, so now I'm not writing now in a command window. We will write using a file, right? So if you have to make a file, so you go in a new script. A new script option is over there in the upper left corner. So if you click on that one, so their untitled file is there, because we have not given any name to this file, so it is untitled file. Now what we will do, we will make the CLC, because once this program will be run, so first command which it encounter with is CLC, means is clear the screen, clear the command window screen, and start a press it start a press starting from there, right? So CLC is the clear command, is used for clear command. Now in this clear command, we after this one we want to plot I write in it here, we want to plot a sine function, right? We want to plot a sinusoidal function, right? Plotting a sine function.
It's not visible.
It's not visible. Okay, sorry, yeah, so I have to again share the screen, right? Because here there is a problem. If I change screen from command window to MATLAB file, then I need to change screen again. Okay, now is it visible?
Yes, sir.
Okay, so this is a file I have made. Once you go in a right click and new script, so after new script, this file is created. I have not given them name, so it display untitled star. Star is indicate that something is missing. What is missing? The name is not given, right? So that is the name is not given, and then the plotting a sine function we will start from here. Now we want to plot. So if you are plotting something, right, t versus the graph of sine. Okay, so is it audible? Hello.
Yes, sir. It's audible.
Okay, so now what we are going to do is we want to start. Okay, so what we are going to do over here is that we for every variable t, that is we can have it we want to data, so we create a vector of t first, right? We create a vector of t. So how we create a vector of t, let's say we want to plot only one graph of sinusoidal from 0 to 2 pi. So I write 0 to 0.1, means start from 0, the time axis. The first we need to create a time vector, and for each value of time we want a amplitude value of sine function, right? So you can define, you can imagine like this: there is a sinusoidal function, and from 0 to 2 pi we will divide a step size of 0 every time 0.01. So the first element is 0, next would be 0.001, then next is 0.02, then 0.03, like this, and it will converge up to 2 pi. It will converge up to 2 pi, right? So this create, what this will do, that create time vector from which value, 0 to pi, right? It's 2 pi, sorry, 2 pi. Pi we write as a pi means it's a pi, it is considered, MATLAB will consider as a pi. 0 to pi with the step size, what is the step size here? The step size is 0.01, right? Okay, so you can write like this. Now we want to plot the graph, so that we assign amplitude value somewhere here. Okay, then we write sine is a command which display the sine. What we write here, 2 pi f0 t or omega 0 t. Omega 0 t we simple write as a 2 pi uh, f0 t. For every value of t we have a new value. So if t has a 1000 value, if this vector has a size of 1 cross 1000 value, so amplitude for every value of t, the sine function is calculated and assigned in a y. So y is also a vector with 1000 values, but the difference between t and y is that t defines the x-axis and y defines the amplitude or y-axis, right? Okay, so that is the way. So what it display, uh, it finds the amplitude values for vector t, right? For vector t, finds amplitude values for vector t. Then we want to plot, so we simply plot is a command which plots the things, and for plot we have to write the x-axis value and y-axis value. So x-axis is our t and y-axis is a y, right? So we plot simply t cross y. Okay, so thing is almost done. One missing thing is f0 is not assigned anywhere. So we assign f0 here, because before use of that variable you need to assign. If you are not assigning that value, then MATLAB will shows the error, because MATLAB will find the value of f0, but it has not find any. If it doesn't find any numerical value of any variable, that will display the error. So better before use of any variable you assign the value. Prior to this, prior to the use of any variable, we assign the value, right? And that defines the frequency. That defines the frequency. Okay, so this is one part, and what is this one? It will be plot the graph. Right? So I think you understand this one. Only this part, this part, comment line will not be executed. It is for our understanding. Okay, so now I run this one, and it will be asked me the name. So I will the name as a first experiment. You can store anywhere, huh? You can have a options over here in window. You can store. I just write experiment number 1. I think it's visible, right? Experiment number 1.
Yes, sir, it's visible.
Okay, so that ask me we need the permissions. Okay, we write. Okay, so now it is stored as experiment number 1. They will ask for change the folder and add to path. Change the folder means you want to store in some other folder, and add to path means it will be added in a path of C. Anyone you can choose. Okay, so once it will be done, then there is a option of run. If you run this one, so this graph is created. This graph is created. Okay, why there are multiple such kind of things? Because the frequency, okay, so we don't need to define 2 pi is by default, huh? So if we write f, okay, again run, so it we expect there should be 10 cycles in a there would be 10 cycles of sinusoidal signal within the 0 to 2 pi. So are you able to see this graph?
No, sir, graph is not visible.
Graph is not visible. Okay, so I need to again share the screen with you. And that is the main loopholes of this team. Okay, now you are able to see the graph.
Yes, sir.
Right. So
Yes, sir.
what is there? The values are, you can see, from 0 to 2 pi. 2 pi is approximately 6.28 because pi is 3.14. So 2 into 3.14. So it is 6.28. So somewhere here you can see, I think, my arrow. So somewhere here 6.28. So this is x-axis. This is a time vector. It just define a time vector, and this is just a define amplitude values. So maximum value of sinusoidal signal is +1 and minimum value is -1. So all the values are punctuated or oscillated between these two values, +1 and -1. +1 is the positive peak and -1 is the negative peak. And how between this 0 to 2 pi, how many cycles are created? It depends on which frequency we have assigned. So we have assigned the frequency f0 is equal to 10, right? 10 means 10 cycles. So that 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 10 cycles are completed. This is the way how we can define. Now in here we have options to change the color of this one. We have options to give the labeling of this one. We have options to give a title of this ones, right? So that is also possible using this. So I will show you that part also. But before this, actually, I need to tell you. So what part is basically we will see in a command window, and I just show you in a command window. This command window is appear. So I simply type T. After running the program, the values are already stored in a workspace. So workspace is a place where your values are stored. So I just type T. So you can have a long vector of T, right? Because we have given the starting point of T0, and means initial point of T is 0, and then step size is 0.01, and then we have given this up to 6.28, 2 pi. 2 pi means 6.28. So how many elements are there? Roughly 629 elements are there, right? And for every value of T, we have found the Y, right? So if Y is a small case. Yeah, there is one more things you have to need to understand. Do not say if you have assigned some variable as a small case, so use as a small case only, right? If so capital and small case, it will be make the difference. So if you write the Y as a small case and Y as a capital, so it will be treated that these two variables are different, not the same, right? Okay, so it's a very case sensitive. MATLAB is a case sensitive. Then if you plot the Y, if you type the Y, so enter, so all these values are plotted, right? How many values are there? Again 629s are there, and then plot will be performed. So plot requires x-axis value and y-axis value should have a same number of elements. It should be matched in a number of elements. Then it can be plot 1 to 1, right? So basically it plot in this way. So plot will simply join down the elements, nearby elements, and then finally gives you a clear picture or clear graph, right? Okay, so they have again 629 elements, T have a 629 elements, Y has a 629 elements. Y display the amplitude and T display the x-axis value, and then we can have a very nice graph over there. Okay, this is a one very important part, and I think this is sufficient for today's session. How to make the graph more interactive by adding some tables and all, and how it is possible to add some multiple graphs in a single in a single graph, multiple graph like a sine and cosine you want to plot in the same graph. So how we can do in a one screen, how we can plot a multiple graphs, all these things that we are going to discuss in a next laboratory session, right? Hope you have enjoyed this session, and then I will came back to my original screen. Okay, so yes, okay, if you have any doubt, then you can ask me questions. I am going to take your presence meanwhile. I am going to take your presence meanwhile. If you have any doubt, batch D, if batch D it's any students of this batch have any doubt, then you can ask me the question. Yes, 50 number, yes.
सर हमने जैसे पहले वैल्यू असाइन की थी ना लीनियर अलजेब्रा के लिए, तो अगर हम मतलब यूजर से लेना चाहें तो
हाँ, यूजर से लेना चाहे तो there is a one command known as a input. Would you like to show this?
यस सर, इफ यू कैन.
Yeah, okay. Yeah, okay. Let's see. I just share my command window with you. If I not, I have not. If MATLAB, I have not. Okay, okay. So I have to reopen the MATLAB, but there is a one command. It takes time. Okay, but next time I will show you that also. There is a one command known as input. Input. So what I write over there, A is equal to actually MATLAB I have closed. That was the problem. Otherwise I will show you. But next time we will see that A is equal to input. Input is a command. Input is a command, and then inside a square bracket you want to write the comment whatever you like, right? And then if you play that, so in a command window it displays the value of variable A, and whatever the matrix you store, that will be stored in a T, and then they will calculate. So by using the input command directly, rather than directly assign the value as a T is equal to 0 to 2 pi with a step size of 0.01 in a file, that we use the command A is equal to input, right? And then if you run this command, so in command window they will ask the value from the users to be assigned, and once we type that value in a form of a vector, then that value will be assigned as a value in a T, and that it all this function will be done based on this, right?
Yes sir, okay then.
Okay, is anybody have any question? And like as an input, if you want to display the value, so we have another command known as a printf. So input is actually a command to take the data from user end, and print is a command. Printf is a command to display the data on the computer screen. Okay, if anyone have any question now, okay, so we just conclude this session over here. Hope you have enjoyed this MATLAB laboratory sessions, and now we will meet in a next laboratory sessions. But we will meanwhile we will meet continuously in our lecture session. So have a nice day and good day to all of you. Okay, have a good day.
Thank you sir.
Thank you, sir. Thank you, sir.
Thank you sir.